Welcome to this video lesson. In this video, we will be practicing some questions which use two-dimensional vectors for velocity and displacement type questions. In the first question here, we have a ball which is thrown at a speed of 20 meters per second, 30 degrees above the horizontal, okay? Taking positive x to be the forward direction. Okay, so positive x, I'm gonna label it here. And taking positive y to be the vertical direction. So x and y are positive in these directions. Determine the x and y components of the velocity. Let's draw the situation out. We got the horizontal, which horizontal line looks like this. And we are throwing at a speed of 20 meters per second, 30 degrees above the horizontal. So here is the horizontal, 30 degrees above that would be somewhere here. I'm going to draw my vector. When it says the speed is 20 meters per second, that means the speed without the arrow, that's the magnitude of this velocity, is 20 meters per second. And the angle here is 30. And what we want is we want to figure out the x and y components. So x component will be in this direction, and the y component will be in that direction, at least the positive ones. So from here, we are going to try to get to the from tail to tip horizontally and vertically. So if we go horizontally, we're going to go from here to here. I'm going to draw that with pink. And that's going to be our horizontal component, and our vertical component. From here we're going to go up to reach the tip. So we pretty much go horizontally until we reach the tip, and then we go vertically to reach the tip. And you could do the opposite. We could go from here first and then here as well. It will give us the same final answer. I'm going to label this as Vy, and that's going to be the y component of my velocity. Now, if I want to find Vy here, that is opposite to my angle. And I'm going to use SOHCAHTOA. And for opposite and hypotenuse, I have to use the sine ratio. So sine of theta is equal to Vy over the hypotenuse, which is 20. And my angle here is actually 30. So I'll put that in. So then rearrange and I will get 20 sine 30. Note that I can just skip to this step, and once you get better with these questions, after doing them 4 or 5 times, I highly suggest that whenever you want a component, you just use the sine ratios and you go right into the shortcut. The y component here, since it's opposite, it's the hypotenuse multiplied by sine of the angle. So start skipping this step as soon as you can and feel comfortable. So I do the value. Sine of 30 is 1/2. If I multiply these, I will get, I'm going to do an approximation sign. Vy, that's going to be 10. And my final answer should be good to 3 significant figures, because this is 3 significant figures and this is also 3 significant figures. My unit for the speed in that direction is just meters per second. So if I want that component, then I'm going to write it as a vector, and that's going to be approximately 10 meters per second in the y direction. Now we have the y component. That means that the magnitude here is 10. It's pointing upwards, so we kind of take it as a positive value in the y direction. Now let's do the x component, and I'll do that using a different color. Let's use blue, and we got Vx is equal to, so for Vx, I'm going to go right into the shortcut, and Vx is an adjacent to my angle. So I'm going to multiply the vector itself, which is 20, by the cosine of my angle. Again, if you're not feeling comfortable and if you need to do the first step, it's cosine 30 is equal to the adjacent over the hypotenuse, and then that's how we get from here to here. But I do want you guys to get comfortable enough to go right into this step as soon as you can. We plug in the values and we will get 17.3 approximately meters per second. And to write this as a vector, it's 17.3 meters per second in the x direction. And I'm going to highlight both of my answers here. And this is how we break things down into components. We basically just look at the magnitude of our vector and we use the sine of the angle and we multiply it by the magnitude to find the opposite component, and for adjacent we multiply the hypotenuse by, or the magnitude of the vector, by the cosine of the angle. And just to give you an idea, usually these, I assume that you guys will be good enough to be able to do this in one step, and in order to find the two magnitudes, you might get a mark or maybe a maximum of 2 depending on the situation, just to state the values, because it needs to become a very easy thing for you to do as you do more and more practice on it. Let's look at the second question here. We got the x component of the velocity of a ball is 25 meters per second, and its y component is negative 15 meters per second. Determine the velocity of the ball. We can certainly do that. We got the ball here. The ball will have an x component of velocity, which is 25 meters per second, and a y component, which is negative 15 meters per second. So I'm going to take my positives to be up and right. So this is x, this is y, and I will highlight this as well. Now I have the x components and I have the y components of the vectors. I'm going to draw them and connect them. So the two components will add up to the actual vector. So starting from here, I'm going to draw my Vx first. And you can draw your Vy first too, it doesn't really matter. This is Vx. It has the x component of velocity has a magnitude of 25. On the tip of that, I'm going to add the tail of the other vector, and this has a magnitude of 15, and this is Vy, and magnitude is 15. So the vector will start from the tail of the first vector and end at the tip of the very last vector. These two make a 90-degree angle, and I'm going to use that idea to find the magnitude of my velocity here. Okay, so for the velocity, if I want the magnitude, I also need an angle later, but for the magnitude, I'm going to use Pythagorean theorem. So v squared is equal to 25 squared plus 15 squared. So v will equal to plus or minus square root of 625 plus 225. So that's plus or minus square root of 850. And if I do this on my calculator, approximately, I need to leave my final answer to 2 significant figures. So this would be approximately 29 meters per second. And that's just the magnitude. You can see that I'm showing it as a speed and it doesn't have a direction yet. I'll put the direction once I find the angle here. For the angle, I have the opposite side and I have the adjacent, so I'm going to use tan. Tan of the angle is equal to the opposite, which is 15. and over the adjacent, which is 25. Note that I'm not using any negative or positive here. I'm just trying to find the angle. So theta is equal to the tan inverse of 15 over 25. And once I put that on my calculator, I will get theta is approximately 31 degrees to two significant figures. And so now I have found the speed. The speed is the magnitude here, 29 meters per second. I have found the angle. The angle is the angle here. And I'll just have to write my final answer. So the final velocity will need a magnitude, which is its speed at the time, its unit, and it needs a direction. For the direction, I'm going to write it as this is the horizontal line, that's x, and it moves at an angle theta towards the negative y. So we can think of this as the horizontal line, and this is below the horizontal line by an angle of 31 degrees. So this is 29 meters per second, 31 degrees below the horizontal. And we can write it like that. If we had a situation in which we had dedicated this to east and north, we could call it east 31 degrees south, or we can also, I guess, put this, sometimes the way I do this is I write it as it's in this direction and we turn 31 degrees towards the downward direction. And I also accept answers like this as well, as long as you have your positive sign convention clearly labeled. So I would actually prefer this answer and this answer over this because the question is just talking about x and y components and it doesn't give you east, north, or south here. So this would be a acceptable answer, these two. Let's now look at the third question, which is a two-dimensional one, and I'm going to zoom out because we need a lot more space to do this one. For this question, use the unit of kilometer for distance and displacement and the unit of kilometer per hour for your velocity and speed. Okay, noted, so we are going to use units of kilometers and hours instead of our meters and second fundamental units. So that's the first part. I'm just going to shift up so we have a little bit more room to work with for this question. Esther travels from home to school for 4.5 kilometers in direction of 25 degrees north of east. She then travels from school to Curry's for 2.5 kilometers south to purchase some art supplies. And finally, she travels 2 kilometers south, 30 degrees south of west to her friend's house to watch their favorite anime. So there's a few things happening here, so I'm going to highlight a few things. We got initial trip is 4.5 kilometers and 25 degrees north of east, and then 2.5 kilometers south is the second trip, and the third one is 2 kilometers 30 degrees south of west. The entire trip takes 2.0 hours. State the total distance she traveled. So this one, I didn't even include the answer for this. This is a state type question, meaning that I just need a final answer and I will only get 1 mark, and that is for the final answer. Sometimes this might be a calculate type questions where you might get 2 marks, 1 for showing the work and 1 for the final answer, but in this case it's just state, and because of that I will have to make sure I plug in my numbers properly. In this case, she travels initially, total distance is going to be her total distance traveled. So initially she travels 4.5, then she travels 2.5, and then she travels another 2. And that, when I add all of these up, I get 9 kilometers, but in terms of significant figures, these all have one decimal place and I'm adding, so my final answer should have the least number of decimal places, which is 0. And this is my final answer here. Then for the second part, we are to determine her total displacement. So this was a determine type question, so you need to show all of your work for it, and this one requires a good chunk of work, so let's go over it. We're going to start off by drawing out the situation, so that's step 1. And in step 1, I'm going to divide this into 3 sections, so that's from 1 to 2, 2 to 3, and 3 to 4, and we're going to assume that 1 is home, 2 is school, 3 is Curry's, and 4 is her friend's house. I'm going to choose a convention, positive convention, sign convention here, so I'm going to have positive and positive here, and that's going to be my east, and that's going to be my north, and I will highlight this right away. So we have that decided. From stage 1 to 2, I'm going to draw a north and east compass here. And we have 4.5 kilometers, 25 degrees north of east. So 25 degrees north of east is approximately here. And we're going to go for, let's say this is 4.5. I'll draw it long. So let's say here, and this is 4.5. And this is going to have 2 components. For the components, I start from the tail and I move horizontally to reach the head, and then I move vertically. You can also start vertically and then move horizontally, but I like to move first in the direction where the angle is. So the horizontally first, and that's going to be the east component. So I'm going to write displacement 1 to 2 in the east component, and then we're going to have the north component here. So the displacement 1 to 2 for the north components, and I'm going to use these magnitudes here. For 2 to 3, she's traveling south only, so that's from here. She just goes directly south, 2.5 kilometers. And from 3 to 4, she is moving in the direction of 30 degrees south of west. So I'm going to draw my east and north here. And she is starting west, going 30 degrees south. So the angle here is 30. And she is going for about 2.0 kilometers, so 2.0. I don't have the best scaling here, so this is 4.5. This should be much smaller. This 2.5 is not too bad, but this should be smaller, but I wanted to leave enough room so we can see all the angles. So to break this into components, I start from the beginning. I move horizontally to reach the head. I move vertically to reach the tip. This is going to be the displacement 3 to 4 in the east direction and displacement 3 to 4 in the north direction. They're south and west, but I'm going to keep it as east, and I'm just going to use a negative value when I get to it. So step 2 is to actually break them down algebraically. So we are going to have displacement. And this is still 1 and 2, so this is going to be in the east direction and the displacement in the north direction. For this one, we're going to have displacement in the east direction and displacement in the north direction. And for this one, we are going to have displacement in the east direction and displacement in the north direction. First, I will take care of all the directions. So for this one, in the east components, the arrow is pointing in the same direction as my positive east. so this is going to be positive. The next one doesn't have east or north component, sorry, east or west component, so that's going to be just nothing in there. I'm just actually going to put a 0 there. And for the next one, it's pointing in the opposite direction to my positive sign convention, so I'm going to put a negative here. Forgot the arrows here. These are all arrows. Okay, I have these. Now for north and south, this is north, same direction. Next one is opposite direction, and next one is opposite direction. So I will have positive, negative, and negative. Let's do the magnitudes next. For my first magnitude here in the east direction, it's adjacent to my angle, so I'm going to multiply the hypotenuse by cosine of 25, so 4.5 cosine 25. And for the north direction, I'm going to do sine because it is opposite. For the next one, it doesn't have any east or west component. In the north direction, it is negative 2.5. The magnitude is just the 2.5. For the next one, in the east component, it's actually in the east component, that's this one over here, that's adjacent to the angle, so that's 2 times cosine of 30, and for the north component is opposite, so that's 2 sine of 30. I've done my second step. Step 3 is to combine the east and the north component. So the displacement total in the east component is going to be the addition of everything. So that's going to be 4.5 cosine of 25, or addition of everything in the east component, plus 0, plus negative 2 cosine of 30. I put that in my calculator and I will get 2.3463 ... The number continues. I'm going to save it on my calculator in letter A and later on use the exact value. And I'm going to do the same thing for my north direction, and that's going to equal to 4.5 sine of 25 degrees plus negative 2.5 plus negative 2 sine of 30 degrees. I plug that in my calculator and I will get negative 1.5982 ... And I'm going to save that on my calculator as letter B. Now that I have the components, I'm going to start drawing them out. That's the next step. Step 4. My east component is positive 2.34, so starting here, I'm going to move in the positive east direction, and let's say that magnitude is 2.3463. And then in the north direction, I'm going to move negative, so in the south direction actually, for a magnitude of about 1.6. So this is approximately 1.5982. ... And I will connect my vectors starting from the tail of the first one to the tip of the last one. And this is going to be my final displacement. And that's going to be the final magnitude actually. That's the magnitude part. To find the magnitude, I am going to use Pythagorean theorem. That's step 5. And I'm going to skip a step here and get right into it. So the distance between those is going to be the square root of 2.3463 squared plus 1.5982 squared. Excellent. I'm going to plug that into my calculator. And I should get 2.8389 ... I will leave my answer as that for now. Step 6 is to find my angle. And my angle is going to be this angle over here. And I'm going to use opposite over adjacent. And that's going to be the tan ratio. So tan theta is equal to opposite over adjacent. I'll just write it like this. So that means theta is equal to the inverse tan of 1.5982, and I'm using the exact value from my calculator. Make sure you're using the positive values here. And when I do that on my calculator, I should get 34.2613 dot dot dot. And that's my angle. So to express my final answer now, the total displacement is going to equal to, I have to write my final answer in two significant figures, so that's 2.8. My unit is kilometers, and for my direction, it is, so if this is the this is east, this is south, so I am starting east, moving 34 degrees in the south direction, or this can also be read as 34 degrees south of east. And that is my final displacement. Excellent. So 6 steps or 7-step solution to kind of do this displacement type questions, very time consuming, but once you follow the steps, you should be okay. I'm going to zoom out a little bit here and just do parts C and D. Part C, it says to determine the average velocity, the average speed of the entire trip. So average speed is just equal to the distance, total distance over total time. And the total distance was 9 kilometer, and I'm dividing that by 2.0. So that's just going to be 4.5 kilometers per hour. And that's the speed. Note that for the speed, I don't put the arrow. And for part D of the question, I have to determine the average of velocity. So average of velocity, now I will put the arrow. That is the total displacement over the total time. The total displacement is 2.8 kilometers per hour. 2.0, actually I have to put the exact value, 89. And when I do this on my calculator, my final answer should be to two significant figures because both time and displacement have 2. And this is 1.4 kilometers per hour. And our direction stays as is. That's 34 degrees south of east. And this is our average velocity. And I'm going to box my answer here as well. And this is how you can use two-dimensional vectors and apply them into displacement type questions. And it helps you find the average velocity and the displacement. And two-dimensional vectors, as you saw in question 1 and 2, can also be helpful in breaking velocities and displacements into components, or we can use the components of velocity or displacement to come up with their actual vector value, which has both the size and the direction of that vector.